For the SAT, you gotta think outside the box. In the figure above, O is the center of the circle. What is the value of A? From geometry, you should know that radii of a circle are congruent. So line segment BO must be congruent to line segment OC. So we could say that these two angles would have to be congruent as well. So this angle, angle B, is 36 degrees. And as you can see, this is a triangle. And in a triangle, there are a total of 180 degrees. So to find the measure of this angle right here, we would have to subtract 180 with 36 plus 36, which would give us 108. So that is the length of this angle right here. And as you can see, this line, there's a line here, and in a line there are also a total of 180 degrees. So to find the measure of this angle, we would subtract 180 with 108, which is 72. So that is the degree measure of this angle. And again, we have another triangle, this triangle. And as I said earlier, in a triangle, there are a total of 180 degrees. So to find the measure of this angle, we would have to subtract 180 with 72 plus 28, these two angles. And that would give us 80 degrees. And from geometry, you should know that adjacent angles are congruent, and these two angles are adjacent angles, angle A and this angle right here, meaning angle A would have to be 80 degrees as well. So B is the answer. This SAT question is a little weird. When a squared plus 2a plus 4 is subtracted from 3a squared minus 4a plus 27, the result can be rewritten in the form of xa squared plus ya plus z, where x, y, and z are constants. What is the value of y plus z? Since it is written as this is subtracted from this, we take this 3a squared minus 4a plus 27, and we subtract it with a squared plus 2a plus 4. Now we subtract the 2. So 3a squared minus a squared is 2a squared. Negative 4a minus 2a is negative 6a. And 27 minus 4 is positive 23. So what are our x, y, and z values? The x value would be 2. The y value would be negative 6, and the z value would be 23. And the question is asking for the value of y plus z, which would be these two numbers. And negative 6 plus 23 is 17. So that is the answer. Can you solve one of the hardest questions on the SAT? In the figure above, the circle with center O is inscribed in square ABCD. Line segment AO intersects the circle at P. What is the length of line AP? To solve for the length of AP, what we could do is solve for the value of AO and subtract it with the radius of the circle. That way it would give us the length of AP. First, let's solve for the length of AO. How do we do that? Well, if we draw a diagonal right in the middle of the square, it would create two right triangles. Angle D is obviously 90 degrees, and if this is a square with a diagonal intersecting it, these two triangles would have the same exact measurements. So the value of this angle would be 90 divided by 2, which is 45. Same thing for this angle. So this is a 45, 45, 90 triangle, which is a special right triangle. Why is it special? Well, if the two legs have a length of x, then the hypotenuse would be x root 2. If we apply that formula here, we know that the legs have a measure of 2. That means that the hypotenuse would be 2 times root 2. So that is the hypotenuse, the diagonal, the length of the diagonal. And this line, line AO, is just half of the diagonal. So we divide 2 root 2 by 2. 2 root 2 divided by 2 is the square root of 2. So the length of AO is the square root of 2. Now how do we find the radius? Well, we know that a side of the square is 2, meaning this line over here, the diameter, has a length of 2. And the radius is just half of the length of the diameter. And 2 divided by 2 is 1, so 1 would be the length of the radius, meaning this length, PO, has a length of 1. That is the radius. Again, to find AP, we just subtract the length of AO with the radius, which is 1. So that is the length of AP, meaning the answer has to be D. You shouldn't be getting this SAT question wrong. The figure above shows the complete graph of the function g in the xy plane. Which of the following must be true? Whenever you see a function, the value inside the parentheses is our x value, and the value that is set equal to the function is our y value. So let's see if option 1 is correct. We look at the x value of -3, which is over here, and the y value that goes with the x value of -3 is 2. So I'm going to write it over here. G of -3 is equal to 2. So this is correct. Now we go to the second option. G of 2 is equal to -3. We go to the x value of 2, and the y value that goes with the x value of 2 is 2. So I'm going to write it over here again. G of 2 is equal to 2, and 2 is not equal to -3. So that is not correct. And finally, we look at option 3. G of 1/2 is equal to G of 2. First, we would have to evaluate G of 1/2. Again, we look at the x value of 1/2, and the corresponding y value is 2. So G of 1/2 is equal to 2. And as we solved for earlier, G of 2 is equal to 2. So we could say that these two functions are equal to each other. So that option 3 is correct, meaning the answer is... This SAT question requires a little thinking. Which of the following consists of the x-coordinates of all of the points that satisfy the system of inequalities above? As you can see, 3y is present in both the top and bottom inequality. So my first goal is to isolate 3y in this inequality. So let's bring it down over here. X is less than 3y plus 4. To isolate 3y, we would have to subtract 4 on both sides. That would give us x minus 4 is less than 3y. And I'm going to bring down the first inequality. 3y is less than 7. So using these two inequalities, we could form a compounded inequality. 3y would be the middle term, and x minus 4 is less than 3y, and 7 is greater than 3y, so it would be on the right side over here. And from this compounded inequality, we could reasonably infer that x minus 4 would have to be less than 7. And now to isolate x, we would add 4 on both sides. That would give us x is less than 11. So D is the answer.